thanks to the speakers. And do we have any questions for either Bhavesh, Avishai, or Hisandu? It's a tough session.
Hello. I have a question for Avishai. This is about the representation that you have for the genomes. In the portion that is representing the variants, do you have a little bit more information regarding how you handle any prediction information or anything regarding whether they are malignant or predicted to be beneficial or none? How are you passing that information on?
Oh, so you're asking how we pass information to like models, inference, that kind of thing?
So I'm trying to grasp the concept of what does it look like once I inject all of this information for GenomeKit. And you said, well, here's GenomeKit, variants are first-class citizens.
Yeah.
How are variants represented, I guess, is a better way to ask this.
So you can create variant objects the way that I saw, and you can apply them on the DNA. Inside the data structure, like their struct is really just like an interval in a trench coat.
Yeah.
Like an interval plus that the information about exactly which things that we change inside of it are. So in our data structure representation, you'll generally see, if we're representing, for example, a VCF file, it'll be like a very large array of intervals plus plus, that kind of thing. Does that answer your question?
Yes.
Okay.
And do you have any decoration about those representations, or is there any annotation about the influence of this particular variant to the region of the genome?
So yes, like I said, it has an interval. So the interval would also encode which chromosome it's on, which strand, the start and end index. And if it comes from this VCF file, we also store all the extra metadata that comes into the VCF, so it's easy for you to access directly. No worries.
So I have a question for Bhavesh. I was wondering if you would consider adding support for GitLab to CodeFair.
Yeah, if there are people happy to help us out, we definitely would, yeah. We started with GitHub because that's what we use, and we were like surveying people, and we found out most people were using GitHub. But hopefully the goal is to make it valuable wherever people are coding, including GitLab, yeah.
Yep. I had a question about GenomeKit as well. Yeah, sorry. Very, very neat tool. Like, you're bringing C++ level speech to Python, which is very neat without needing to install HTS-lib is very efficient. So my question is related because I see that, on your presentation that you have the full functionality of PySam and stuff like that. So do you have that converted to your GenomeKit as well? Do you get the full functionality as you would in PySam to access BAMs and stuff like that in GenomeKit? Because I saw you comparing it.
So we have multiple parsers inside of GenomeKit from BAM, SAM, VCF. You convert them once into the GenomeKit representation, and then you have all the information inside like the GenomeKit type data files. Like that. I don't want to say proprietary, but they're open source. So yeah.
I see. So there's a pre-processing step needed.
Correct. You need to do that once. The processors themselves are also kind of hyper optimized, so it's faster than others that do similar conversions. Like I've seen conversions like TBI, etc. But it's faster. But it's a one-time operation that you need to do. Yeah.
Let's chat now.
Thanks.